Hi, this is the finite state machine assignment for simple car alarm system using Quartus. So this is the coding for the first car alarm system having 3 states, which are idle, active and hack. So for this version, the password should be 101. After compiling this coding, we can see this is the FSM from the Quartus. We can compare that it is quite similar to the one that we see from the slide. Now we can use the programmer to compile it into the FPGA board. So this is the FPGA board. As we can see here, there is a green light at LED G0. This one is indicate that the code is running inside the FPGA board. So this is in idle state. When pressing the key 3 button, now the FPGA is in active state. When it's in active state, we can press the key 2 button so that it stops back to idle state. Now during the active state, we can press key 1 so that it will go to hack state. If you can see here, hack state shows 2 LED light indicating that both activate and alert are on. So during this state, hack state, we need to key in the password. As you can see, no matter what password I key in, the hack state is still on as long as I input the correct password, which is 101. After inputting the 101, then the hack state will transition into idle state back. So that's how the car alarm system works. So this is the second version of the car alarm system that uses 8-bit password instead of 4. So the process is basically the same as the V1. The idle, the activate and also the hack state are pretty much similar to the one previous. So in this version, the only differences is that instead of using only one LED, we use the whole LED for both activate and also alert. And then for the password, this time I'm using 8-bit, so the password I've set it is 1001 1101. So this is how similar but with longer password and also more LEDs used.